Okay, today we are going to talk about the Pythagorean theorem and what the Pythagorean theorem is and what it is used for. So the Pythagorean theorem, you know what, before we say what it is, let me explain a few parts. When you have a right triangle, there are two segments that are called the legs. And the legs are the part that are making up the right angle. Okay, so if this was our triangle, the legs would be these two green sections. They're what's making up the right angle. And C is going to be what's called the hypotenuse. The hypotenuse. So if this is our triangle, the hypotenuse is this part. Okay, so legs are the two that make up the right angle. Essentially, the legs make the L, and then the hypotenuse is the slanted side across from the right angle. And what the Pythagorean theorem states is that if you take a squared plus b squared, okay, the two legs, and add them together, you're going to get c squared, the hypotenuse. Okay, so the Pythagorean theorem tells us that if I square the two legs, I'm going to get the square of the hypotenuse. So let's talk about what that means, or let me show you a visual. So this is a right triangle. This right triangle has a left side of 1, 2, 3, 4 units, right? You can see that's 1, 2, 3, 4. So if I squared it, right, 4 times 4, that would give me 16. We can all agree 4 squared is 16. There's 16 little squares in that box. Okay, then if I squared, this side is 3 units. 3 squared, 3 times 3 is 9. So here are 9 little squares. So let's look at what happens when I put them together. So first of all, this hypotenuse is 1, 2, 3, 4, 5 units. 5 squared is 25. So let's look at the 16 from over here. 1, 2, 3, 4, 5, 10, 15, 16. Okay, plus 9 made 25. If you have a chance, if you Google or look on YouTube for Pythagorean theorem waterproof, there's actually like it's this really cool little wheel, and it's filled with water, and they spin it and show you that these two legs squared, when you put them together, will fill up the hypotenuse squared. So let's do some problems with it. So Pythagorean theorem is used to find the missing length of a right triangle. So for example, on number 1, okay, it's telling us that the two legs are 5 and 12. So 5 squared plus 12 squared is going to equal this missing side squared. 5 squared is 25. 12 squared is 144. Okay, and if you're not sure, you're allowed to use your calculator. So you can type in 5 squared, 12 squared, and then if I add them together, I should get x squared. So 25 plus 144 is 169 equals x squared. But I don't want to know what x squared is. I don't want to know how many little squares are up here. I want to know the length. What number times itself is 169? So on our calculator, we are going to take the square root of 169. On this calculator, I hit second, and then the square root key, and I type in 169, and I get 13. And that would be my answer. Okay, let's look at number 2. On number 2, I have 6 squared plus 10 squared equals x squared. So 6 squared is 36, 10 squared is 100, 36 plus 100, 136 is x squared. So again, I want to know what number, when I square it, gives me 136. we are going to round to the 10th place. So this is not a whole number. There's no perfect square for 136. So I'm going to take this as 11.7. And the hypotenuse is always the longest side, so that's kind of a quick check, like, okay, yeah, that's 13, that's longer than 5 and 12. This one is almost 12, that's longer than 6 and 10. And then the last one, we have 8 squared plus 10 squared equals x squared. 64 plus 100 is x squared. 64 plus 100 is 164. And then the last step is to take the square root of 164, which is 12.8. This 0 is not enough to raise the 8, so 12.8 equals x. Okay, so you have a homework assignment for part A, which is when you're missing the hypotenuse, so go ahead and work on that. And then tomorrow, when you need to watch the video for part B, you're going to pick up right here where you left off. Okay, so let's talk about part B, which is what if you are missing one of the legs? If you're missing one of the legs, we can kind of manipulate the formula a little bit, and we can write it. So normally it's a squared plus b squared equals c squared, right? And it works and it makes sense because we're missing c squared. Well, what if b squared is what I was missing? Okay, so if I have c squared and I know a squared, all I'm going to do is write my formula as c squared, I messed this up already, minus a squared equals b squared. So we're going to do the hypotenuse squared minus the leg that I know squared to get the missing leg squared. Okay, let me show you an example. So on number 4, yesterday we would have said 6 squared plus this number squared equals the hypotenuse squared. But now we know the hypotenuse. So we're going to do 14 squared minus 6 squared equals x squared. Okay, we're subtracting instead of adding. So only when we're missing the leg. So 14 squared minus 6 squared. So 160 equals x squared. The square root of 160 is 12.6 equals x. On letter B, again, we are missing one of the legs. We have the hypotenuse and a leg. So I'm going to do 17 squared minus 9 squared equals x squared. So 17 squared minus 9 squared, 208 equals x squared. Well, what's the square root of 208? 14.4. And then on number 6, same thing, right? I'm missing one of the legs, one of the parts that's making up this right angle. So I'm going to go ahead and do 20 squared minus 12 squared equals x squared. So 20 squared minus 12 squared, 256 equals x squared. Now we're going to need to take the square root of 256. That's 16. So 16 would equal x. Okay, and I'm not super picky about it, but you would need to have, or you should, and I didn't write it on here, feet, centimeters, and miles. But I'm not going to count off if you don't have a unit on that. Okay, and then I have one last question. It's a word problem. So it says, a 18-foot ladder is leaning up against the house. The top of the ladder, so actually what I'm going to do is I'm going to draw this house first. There's our house. And then we have a ladder. Here's the grass. Look at that beautiful house. There we go. Okay, here's our ladder. Jump, 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 jump. Okay, the ladder is 18 feet long. It tells us that. Okay, the top of the ladder is 15 feet off the ground. So this right here is 15, right? The ladder is 18 feet. It's 15 feet off the ground. So the question is, how far from the base of the building is the base of the ladder? So this is what we're missing. Okay, and that is going to be a leg. So I'm going to set it up as the hypotenuse squared minus the leg that I know squared equals the missing leg squared. So on my calculator, 18 squared minus 15 squared, 99 equals x squared. The square root of 99 is 9.9 equals x. So it's 9.9 feet away from the base of the house.